This is a video tutorial on how to use an Autel drone for mapping purposes, in order to achieve the objectives of the BSB ECO Monitoring Project. When planning a drone mapping, it is of the highest importance that the user is familiarized with the survey area, and to plan the mission ahead. To start using the Autel drone mapping, open the application on the smart device. Once the application starts, the user is presented with two options: camera and mission. Camera is for free flights, and mission is for mapping. Select mission. In this next screen, the application offers several types of missions depending on users' requirements. The most common and less time-consuming is the rectangular mission. Select rectangular. If the smart device that the user is using for this mission planner has a good GPS signal, the application will automatically determine the location and place the user on the map. Now, on the map screen, navigate to the survey area and press the plus sign in the middle of the screen. This will automatically generate a mission by default. At this stage, the user can still navigate the map and easily use the control points to rotate and pan the mission at his convenience. Also, he is presented with control points that can alter the flight plan on its length and width, thus increasing or decreasing the flight lines. The application automatically determines the time required to execute the flight, the area in square meters, and the number of photos with every modification to the flight plan. The flight plan should have the starting point as near as possible to the landing area, in order to preserve the battery. It is best to first insert the flight parameters like flight altitude, speed, photo overlap, etc. This can be done by using the menu on the bottom of the screen. The user can save the mission and name it to his convenience. The user can still make adjustments to the geometry of the flight plan, with the updated flight parameters. Going back to the main screen and pressing again mission button, the user can access the planned mission in the mission history section. He can now start the flight, or make further adjustments. Before leaving in the field, make sure that everything is packed and that nothing is missing. It is very important to have 1 or 2 power banks to recharge your phone and drone's remote controller. In the field, recheck every drone battery, and make sure that they are fully charged by pressing once on the power button. Take the drone out of its carrying case and carefully expand its arms and propellers, as shown in the demonstration. Then, carefully remove the sensor protection and place or replace the battery for the mission ahead. Place the drone on the desired landing spot. Then, take out of the box the remote controller of the drone, and expand its handles and its antennas. Place the smartphone in the dedicated location, and connect it with the RC using the provided cables. After a quick check of all dependencies and locking everything tight and safe from the wind, the user can now power up the remote controller. It takes a few seconds to boot up, and when it asks for connection, please power up the drone. When these two are connected, the message "ready to go" appears on the remote controller's display. At this point, open the mission application on the smartphone. Tap the mission button and load the mission that was saved for this survey. The user now can quickly check its position and landing spot in relation with the planned mission. Also, he is able to do further adjustments and review the flight's settings. When everything is ready, tap the Start Mission blue button on the right and press Fly to begin the survey.
Flying to starting point.
After the completion of the flight plan upload, the drone will automatically fly to the starting point and begin following the flight lines and taking pictures along them according to the flight's settings. This procedure is entirely autonomous and it requires no further input from the user. During the mission, the user can switch between the mission overview screen and the camera of the drone to observe the land below. It is important, and also according to the regulation, that the pilot must keep the drone in sight during its flight, abort the mission if in danger, and always be prepared to take informed maneuvers. During a mission on hot summer days, it is recommended to keep the remote controller and the smartphone in the shade, to prevent overheating and loose link with the drone. When the survey is finished, the drone will automatically land from where it started, with no user intervention needed if otherwise. With the drone landed, switch off the remote controller and the drone's battery, and begin packing up tidily and with caution. Make sure to let the drone's battery cool down during packing. Carefully lock down the sensor's protection, fold the drone's propellers and arms, secure everything in the carrying case, and with this, the survey is done. Back in the office, in order to download the pictures, access the micro SD card from the side of the drone, insert it in a card reader, and copy its contents on a computer terminal for processing the data. In order to stitch all photos into a single geo-referenced one for further analysis, the user is presented with several software, both freeware and licensed. For the purpose of this training, a licensed software will be used to make this processing, entitled Pix4D. The approach in getting an orthophoto and the DSM out of the pictures is a straightforward and user-friendly process. Open the application, name and save the process. Then import the photos, define the geodetic parameters, if necessary, then choose a pre-made template, according to the desired output. The application will then load all the picture centroids on the map, from where the processing can begin. The first step out of the three is the initial processing. This is where the application identifies all the tie points between the pictures for further analysis. It also generates a quality report, which is very helpful to identify the anomalies and the issues that may occur during this first step. It details the number of valid pictures, a preview of the DSM and also of the orthophoto. The second step of the processing is to generate high-density topographic points, point cloud and mesh. The application is able to export LAS files which can be imported in third-party software for further analysis. Again, at the end of the step, the quality report is enriched with this new info. The application is now able to load these high-density points, as shown in the demonstration. The third and final step is to generate the automosaic. The resulted GIF file is able to be loaded in any GIS software for further analysis. This was a detailed training on how to use a drone for monitoring the environment, using RGB sensors with some basic recommendations on how to process the data. There are numerous ways in doing this, both freeware and commercial. Pix4D is certainly the best commercial option in processing this type of data, and within this tutorial, it was tackled only the basics of what the software is capable.